Okay, this is lecture chapter 2, section 2, velocity and momentum. Velocity and momentum. Make sure you look at these essential questions, review vocabulary, and the new vocabulary. There will be a vocabulary quiz. Okay, so velocity. Here's the deal. Yesterday, last couple days, we've been talking about speed. You solved some speed problems. Velocity is speed of an object with a direction. So if I tell you, basically, if I say I'm going down 70 miles an hour, down 71, I've told you my speed. If I say I'm going 70 miles an hour, down 71 south, I have given you my velocity. The only difference between speed and velocity has a direction. Okay. So right here it says velocity and speed, and it's showing a picture of some race cars here. These cars can have a constant speed. They could have a constant speed. These race cars could. But since they're in a corner, they're changing direction. Okay. And since velocity is changing direction, it's speed with direction. Because they are changing direction here, they are changing velocity continuously as they go around this corner because their direction constantly is changing. Okay, so speed with direction is velocity. Okay, so here we have, excuse me, here we have some people that are moving the same speed. Okay, these escalators are both the exact same speed. Some are moving up, some are going down. Same speed, different velocities. They have different velocities because they are going in different directions, down, up. Okay, so remember, velocity is speed with direction. And even though, again, I'm going to say, even though these people on this elevator or on these escalators are moving the same speed, they have different velocities because one's going up and one's going down. Okay, so in the last notes, I talked about relative motion, motion you are unaware of right here, motion of the Earth's crust. This is plate tectonics. There's going to be a small question on the homework over this. Okay, it is relative motion. It's motion that you are unaware of. But this plate tectonics deals with velocity because all of the plates are moving in different directions. Okay. And they cause changes such as mountains, earthquakes, volcanoes. Um, the Atlantic Ocean is getting bigger, the Pacific Ocean is getting smaller, and it's all because of plate tectonics. Okay. And if you look at this right here, this gives you an idea. The uh, Australian North is moving north at 17 centimeters a year. Okay, so they're not moving very fast, but then again, 17 centimeters is quite a shot. And that brings us over here to relative motion. Relative motion, motion you're unaware of. Okay, and this is going to explain how if you're sitting still in this house and there's a hurricane coming, okay, it's going to hit this house in a certain amount of time. Where here, if you're in the car moving away from it, it's going to take longer for it to get to you. It will because you're only going 18 kilometers an hour and it's moving 20 kilometers an hour. It will catch you, but it's going to take a little longer just because you're driving a little bit slower than the hurricane. All right. And again, relative motion. And here's some more explanations here. So make sure you're reading this stuff, you're looking down through it, and if you have questions, you need to ask me. Okay, you need to ask me these questions. All right. Then we jump from velocity. Remember, velocity, speed with direction. Okay, speed with direction, and we will do a few velocity problems coming up. Don't worry about that. Woo woo. Right. All right. Momentum. Um, Momentum is equal to mass times velocity. Momentum of an object is the product of its mass and its velocity. Momentum is usually represented by the symbol P. I think the reason they use P for momentum is because mass and meters both use M, and adding another M is just going to be confusing. So we use P for momentum. Capital P is pressure. So we're going to have to use that lowercase p. And momentum is just the mass times the velocity, okay? And again, we will do a few momentum problems here in the next couple of days. But you can see how a car and a semi truck have different, it takes a lot longer to stop a semi truck than it does a car. And it's because the mass is so much larger in a semi truck than in a car. It takes longer to stop this if they're going the same velocity, if they have that same speed. Remember, V is speed, P, momentum, M, mass. All right. Can these both have the same momentum? Absolutely. Okay. Absolutely. Um, some other things when we think about momentum, think about a train, how huge a train is. Um, if a train's coming down the track at a slow speed, it's still going to have a huge momentum because its mass is so high. All right. Um, a bullet, if you deer hunt, a bullet has a high momentum. This momentum is what kills the deer. Bullet has a very small mass, but it has a huge velocity. The faster it goes, the more momentum that bullet has, and the more damage it's going to do. Okay. So that's why a small caliber rifle like a 223, they're deadly too. A 5.56, they're deadly because they have a high velocity. Yeah, they don't have the mass of a 30-06 or a 308 or a 44, but they move faster. So they have a high momentum. Okay. All right. That's it. Make sure you read your review. You should be able to answer these questions right here. And again, if you're confused, meet me in office hours or ask me in class. I hope this helps everybody. Make sure you read through it and you learn this material as much as you can. Thanks.